And I think I even heard a rumor that the bar was open during the break. Bar is open during the break, but not before the break, so don't leave. I know you want to drink quick. Okay, so up next we have Matt Campbell, and his interesting fun fact is he rode into his. I spelled road wrong on my. Oh, actually no, I spelled road right. Rode into his wedding on an elephant. So there you go, Matt. Take it away.
Hi, thank you. Cool. So my talk today is Chaos Monkey on my laptop, and it's kind of just a journey of a post-mortem of how we went from no testing to actually being able to do chaos testing. Just like a quick show of hands, who here knows what chaos testing or chaos engineering is? Oh wow, so it's actually a good portion, like 3/4 of the audience. But for those that know, is basically Netflix popularizes the tool called Chaos Monkey. And basically what they did was they randomly would kill servers in their production environment and made sure that their stuff kept running. Which is kind of crazy when you think about I don't like to touch my production environment, let alone just randomly kill stuff in it. Now anybody here actually use Chaos Monkey? One hand. Okay, this is good, because my whole talk is about how I don't like Chaos Monkey and how we should do a lot better in the Go community, actually. Cool. So just really quick about me. I'm writing a book called Microservices in Go with Riley. I spent the last 4 years at Thomson Reuters building an instant messaging system. And I used to be a Rails dev, so really cool. So about 4 years ago, Thomson Reuters approached me and actually one of the other speakers, Paul Dix here, and they said, we have this instant messaging server we're writing in Java, and we have 200 developers on it, and we can't actually ship it. 270. I forgot. And they're like, could you do a little bit better? And we're like, yeah, I think we could do a little bit better. So we took about 6 Go developers, and we actually built their entire instant messaging system in Go from the ground up into production. But this is a kind of a screenshot of it. So basically, you can think of it as Slack for financial professionals. So if you're a stock trader, you can share charts, or you can share tickers, or any kinds of these kinds of things. And it has all the kind of standard instant messaging. So it's like the textbook Go application. So it was really awesome kind of fit for Go. But it had some special properties. So we had 300,000 users. And they're at pretty much every major bank in the world, from little small banks in Southeast Asia to Deutsche Bank to Bank of America. You name the bank, we're probably there. And people were actually making money on this system. So they were doing tens of thousands of dollars in trades a day. So any time downtime was actually costing them money. So they would be very, very angry with you, as you can imagine. So I'm not going to go into a whole lot about our architecture. I have another talk online if you're kind of interested about doing an instant messenger in Go. You can kind of check my other talk out. But so basically the talk today is about our testing. So when I originally came in the project, we had 11 QA engineers to 6 developers, which is kind of a crazy setup, but it was probably the most awesome thing that I've ever had in my life. Because basically for every release, we could do every kind of testing. We had some guy that would do a performance test. We had one guy that would randomly kill processes on machines. We had a guy that would try to disconnect networks and load the database, or disconnect databases. And it was really awesome, because we were able to actually go out into production in 6 months, and we didn't actually have to write a whole lot of failure condition testing. But kind of what happened over time was the financial community, over the last few years, has kind of got hit. A lot of the banks have been getting smaller. So our QA team went from 11 to 3 to 2 to 1. So we were looking, and we still wanted to push code, so we were pushing code on a 2-week basis, and we wanted to keep pushing. And you can't break things in the financial community. It's not like in startups, you go we're gonna run things, and if we break it, whatever. No, we can't really do that. So we had the brilliant idea. We're oh, we're gonna just get this Chaos Monkey thing. It's gonna be awesome. We're gonna set it up in our dev environment, and all is good. So we kind of set it up, and basically what happened is everybody's the dev environment's broken all the time, and we couldn't figure out anything, and nothing would ever work. So basically we had to figure out how we could crawl, because we wanted to reach this nirvana where we have stuff that would randomly kill databases in production and like everything works, but like we were kind of like this guy, where like basically we had nothing. So really the approach that we originally took was we were really heavy on integration tests. So basically we have an integration test suite where we would spin up clusters of our server. We would literally download Redis, MySQL, Elasticsearch, OpenFire, download and compile and install all these programs and run clusters of this in our integration test suite. And this was really cool until like we had some developers on OS X and we had some developers on Linux. And then one day we got a guy that decided he only would develop on FreeBSD. So our test sh script is like 1,000 lines of code of like, okay, if you're on BSD but it's OS X BSD, so kind of the first thing about this was kind of moving our stuff to Docker. Who here uses Docker in their integration test suite? Nice, we got like at least like 20% of the audience. That's awesome. So the first move of just getting Docker, we tried Vagrant and it was cool, but we found that Docker ended up being really the best because we could actually set up all of our dependencies in our integration test suite. We could figure out the exact versions of MySQL, and like we could actually pin these things. And that was kind of like the first building block of actually having a test suite that was like very easily reproducible. Of course, continuous integration. So everybody here runs continuous integration on every commit? Oh, come on, more. I only see like 10 hands. Oh my God. So that was kind of our big thing. So we started off with these tests. And the first kind of test that we decided to do were performance tests because our system was very performance critical, being instant messaging. So what we ended up literally doing is on every commit, we would fire up a cluster on Amazon and run a load test. And then we'd graph it over time, and if you did a check-in and if it made it go over a certain threshold, we'd have to reject the commits, which was really kind of nice. So none of this is even failure testing. So now we're kind of at the point where we're kind of like crawling. We kind of have like a good test suite. We kind of got the basics going. And now we start to do failure testing. And this is where it was really kind of fun. So one of the first things that we have is if each portion of our system goes down, we just do degraded experience. So for example, if our MySQL master goes down, we just turn the system into read-only mode. You can't update your roster, but you can still do every other operation. But what would happen is over time is we'd get new developers on our team, and they would check in new code, not understanding the assumptions of like what happens when the MySQL master goes down. So one of the first failure tests we actually did was we started to make MySQL masters go down in the middle of tests. And some tests obviously won't work at all, but some tests could actually work. And kind of the main way we did this was we started to do kind of test suites. Does anybody actually use test suites in Go? Like 5. So this is kind of a big thing I've noticed in Go is like, so if you in most other languages, we have like actual suites where like you set up a set of tests. Like in our test, we actually install multiple MySQL servers and we load up databases on them. But like in the main Go packages right now, it's very functional. I'd like to see actually more work done of actually getting kind of test suites. So anyways, yeah, so we started actually, what we do is in the test suite controls the MySQL database. So it could actually bring down a master in the middle of a test. And the way we actually really started with this is we just had explicit tests that say what happens when the master fails. And we actually said, okay, this function should succeed and this one should fail. So like we didn't even introduce chaos at first, and that's kind of how we got to like the next level. I want to talk about mocking. Who really likes mocking here? I saw a lot of giggles. I thought there would be more. So I know a lot of Go developers I work with, they like to mock things. But we really found mocking was really horrible for our problem space because we found a lot of bugs even in the core libraries. So like the connection pooling in Go, like in production, like MySQL would drop connections and the connection pooling library wouldn't notice and we would catch errors. So like if you were to mock your whole MySQL layer, you don't catch these kind of problems. So what was kind of cool about this project is we came into a code base that had kind of been around for 10 years. It had been in production. So we had all these, we had about 17 different APIs that we interfaced with inside the company. And what was awesome is they had 3 different auth services written in 3 different languages with replicated databases of the same data. So we had all kind of cool things in our code, like if this auth service falls over, use the next auth service. But of course what happened on the first day of launch, we took down all 3 auth services. It's fun. So this is kind of was really the next level, was actually each external service that we had in our system, we had to have tests for degraded failure conditions. And I think honestly the hardest part is handling when things go down is fairly easy. It's when things get slow is really bad. So we actually had one auth service that would never go down, but it would take 5 seconds or it would take 10 seconds, and it would actually back up systems. And we actually had to do tests around that. So a random story, I would keep getting waken up at 2 in the morning, and it would at 2 in the morning they would panic and they're like, Matt, we're seeing 10 times the load, the system's slow, and everybody's complaining. So we would all log in, and we would look at the servers, and for 3 hours the system would be slow. And then instantaneously it would go away. And this would happen for 3 days straight, exactly at 2 o'clock, and it would end at 5 o'clock in the morning, every single time. And what turned out, it was a couple users that always went to work at the exact same time. They had a bugged version of their client that would make them log in 10,000 times in a row. And it would just constantly, it was in the client version they had would just log in continuously forever. And we were like, oh, that's cool, so we'll reproduce this in our dev environment. So we reproduce it, and we do a load test of 10 times our load, so 3 million users. And we realized we can handle the load and the system shouldn't be slow. And we're like, oh shit, well, okay, what is it now? So we started to dig in further, and it happened to be that only one of the users had a friend on America Online. And we federate with America Online, and we would send 1 million messages to America Online where they would get so slow, they would start rejecting messages to us, and then we would have gigs of RAM in our memory, of presence messages to America Online for one user. So to simulate this, to make sure that this never ever happened again, I built this tool called the Slowness, which I'm going to open source soon. I'll talk about that later. And basically what it does is it listens on a TCP socket, and it has an API, and you can do things like randomly stop sending packets, or read some, sleep for a minute, or sleep for a second. And we were able to get all kind of really cool slow consumer problems, and actually write an integration test suite to handle and say look, if the downstream pipe backs up for more than this time, we actually dump the messages. And what was funny is we actually had QoS in some of the code, but any code that was connecting to America Online, we said, oh, well, we're not going to throttle America Online. So it was actually really cool because we could use this in our test suite, and we could actually solve some of these problems. So these are kind of the typical problems we had: connection pooling, dead TCP connections. I think the worst is if MySQL runs out of disk space, it will accept connections, but it won't do anything with them. And it's really insidious problem because a lot of times you don't have backups in your SQL layer, and you don't actually time out a lot of times in your SQL layer. So to kind of get back, so we're okay, now we have our failure test in our environment, and we can actually run this in a CI, right? It's okay, what do we do next? So we built this tool called Varn, and apparently a Varn is this giant lizard here, because we like naming fun things. So basically, since our integration test suite had no mocking, we actually just installed it in production, and we gave it specific users, and our integration test suite runs in our production environment. And it does cool things where it can log into individual nodes and it can make sure that node 1 and node 7 can like do instant messages between each other, and so it can do like an exponential graph that you would never be able to do. And you could even do things like you can verify like it's really slow between these two nodes, but it's not really slow between these nodes because the AOL user was on node 7 and he killed everything. So yeah, so this is kind of what, this is awesome. I have my graphic artist make this. So what I'm trying to do now is I'm trying to make this new framework called Chaos Gopher. And kind of what's different than like a lot of these big Java frameworks is we want to do like a Unix style. So like basically internally we made a few tools. So like we made a tool that could like fill disks. We made a tool that could like introduce weird TCP slowness. We made a tool that like could like kill processes randomly or on a controlled basis. And we just made these little tools, and like we introduced these tools into our integration test suite, and we were able to get like 98% of the value without actually having to like just kill servers all the time. And it was like and then I'm sure each person in different teams has different problems. But I felt like these small tools were a lot nicer than trying to create some giant chaos framework, right? So that's kind of like the main takeaway I got from all of this. Kind of going forward from here, what I would really love to see in the Go community that's not really there is better test suites. We use GoCheck, but there isn't really a good test suites set. Flappy tests. So like we had a lot of tests that were flappy, but CI is always red or green. But to me, some tests should be allowed to be flappy because sometimes it's just very hard to make certain tests deterministic. And as part of that, I would love to see statistical difference in flappiness. So like sometimes we would make a change and a test that's flappy would fail every 5 times or every 10 times, but then all of a sudden it would start failing every other time. And there really isn't any good tools, at least I haven't seen. I would love if anybody uses them to like actually manage things like flappy tests and actually manage that in a decent manner. So cool. Any questions? Oh, so I have to go.
Thank you very much, Matt. We actually don't have any time for questions.